Hey 6th grade, this is video 1 for 11.8 notes. If you're following along either in your workbook or on Pearson, you might notice some of these definitions are not actually from 11.8. They're going to be from 10.4. But since we're doing chapter 11 first, it is worth going back and reviewing or actually learning some of these definitions that are going to pop up in this lesson as well. 2 notes before we start. There is a document I attached to the assignment called Basic Geometry Terms. It's just an additional resource there for you that has some of these definitions with symbols and visuals and examples. The more important note is you're not going to be using a protractor at all in this lesson unless you're just using it to draw straight lines. Diagrams are not going to be drawn to scale most of the time, and we're going to actually be using algebra and properties of equations to find angle measures. Okay, so getting into definitions and notations. So first we have a transversal. So a transversal, here we see 3 lines, line T. Transversal is a line that intersects 2 or more lines at different points. So in this diagram here, T is your transversal because it intersects lines M and N at 2 different spots. A big rule, important rule that goes along with transversals. If a transversal intersects a pair or set of parallel lines, congruent angles are formed. So here's where we get to some terminology and symbols that we saw earlier in chapter 12, but if you did not get a chance to go through those notes, let's recap those. So here, this symbol means congruent. Okay, it's got an equal sign and a little swiggle up top. That means that the measures are the same, they're identical, same shape, same size. So if we are dealing with corresponding angles, which we'll talk about here in a moment, then we can assume that they're congruent as long as the lines that we're dealing with are parallel. So here's a symbol that is used to state if 2 lines are parallel. R is parallel to S. And then here's another way you might see it. In the actual diagram, these 2 triangles here are showing you that line R and line S are parallel with these little triangles here. You can never assume lines are parallel. They have to either tell you or they have to give you enough information for you to solve and prove that they are parallel. And here we have a diagram, and here we have 8 different measures, 8 different angles. So we name those 1 through 8. And these arrows here, as we learned back in chapter 3, are telling us that lines go on forever. So the idea of corresponding angles, we'll start here with angle 1. Notice angle 1's in the top left of this set of angles. Notice angle 5 is also in the top left of these sets of angles. This transversal crossing through the 2 parallel lines are what helping us create corresponding angles. So angle 1 and angle 5 are corresponding angles because they're in the same location respectful to their transversal and parallel line. So that means they are congruent. Other pairs of corresponding angles, angle 2 and angle 6, because they're both in the top right location, angle 3 and angle 7, and angle 4 and angle 8. Those are all pairs of corresponding angles, which means they are all congruent to each other. Okay, so I just redrew the image here on page 2 so we can have that to refer to for our further definitions. Here's our definition vertical angles, which actually comes from lesson 10.4, and that means that the angles that are opposite of each other form vertical angles when 2 lines intersect. So I broke the diagram apart and only focused on the top half here and redrew it for you. Okay, so this means that angle 1 and angle 4, since they're opposite of each other when these 2 lines intersect, they are considered vertical angles. Same with angle 2 and angle 3. Okay, vertical angles are always congruent, which remember means same shape, same size, in this case, same angle measure. Okay. Now we know corresponding angles are congruent from page 1 of notes. Now we know that vertical angles are congruent. So I tried to use some highlighting color here. You also see some new notations, these little arches that I drew. You'll see those arches. That means that the angles that have the same number of arches are congruent. So angle 1 and angle 4 are corresponding angles. Sorry, no, they're not. Angle 1 and angle 4 are vertical angles. Angle 1 and angle 5, as we said on the first page, were corresponding angles. Well, if angle 1 and angle 4 are congruent because they're vertical, and angle 1 and angle 5 are congruent because they're corresponding, then it's enough to assume that 4 and 5 have to be the same as well, which means angle 5 and angle 8 because they are vertical angles. So a lot happens here. Whenever you have parallel lines split by 1 transversal, 4 of the 8 angles end up actually being congruent based off these two definitions. Same with the pink. The 2 arches I highlighted in pink, we have vertical angles, we have corresponding angles. So there's multiple ways that you can prove that these angles are actually congruent. And to sum it up with symbols, angle 1 is congruent to angle 4, which is congruent to angle 5, which is congruent to angle 8, and the remaining angles are all congruent as well. This actually opens up many other types of angle relationships. So at this point, you actually do know enough to be able to prove that these sets of 4 angles within all these 8 angles are congruent, but sometimes you might not be given enough information to settle with that. So we are able to use this diagram to create other angle relationships as well. Okay, so here we have alternate interior angles. What this means is that the angles on the inside or in between the parallel lines, but on alternate sides of the transversal, are alternate interior angles, and they are congruent. So if we look down here, angle 4 and angle 5, they're on the inside of these 2 parallel lines, but they're on alternate sides of the transversal itself. So those would be considered alternate interior angles. Same with angle 3 and angle 6. They are on the inside and they are on alternate sides of the transversal, so they are another pair of alternate interior angles. Similarly, alternate exterior angles are going to be angles on the outside or the exterior of the parallel lines, but still on alternate sides of the transversal. These angles are also going to be congruent to one another. Angle 1 and angle 8, they're on the outsides of the parallel lines, but they're on opposite sides of the transversal. Same with angle 2 and angle 7. So that's why those relationships form pairs of congruent angles, which if we went back to the previous page, we already had that written down in our list of congruent angles. Another note, there are many ways you can prove congruence, like we said just a moment ago. Notice that no matter what angle relationship we focus on in the diagram, we end up with the same angles being congruent to one another. And then some of the last definitions, back to lesson 10.4 again. Supplementary angles. Supplementary angles are angles that add to be 180 degrees, whether they're adjacent or not. If they are adjacent, they form a straight line. So, short little mini lesson off to the side here. Here we have 2 angles formed. We can call this 1 and 2. These are adjacent because they share a side. Okay. They form a straight line, which means whatever measure of angle 1 and the measure of angle 2 are equals 180 degrees. They don't have to be adjacent to be supplementary. They can be separate from each other, but as long as their measures equal 180, then they will in fact be supplementary. But we're going to focus more on these for today. Okay, here's some more notations. If angle 1 and angle 2 form a straight angle, the measure of angle 1 plus the measure of angle 2 equals 180 degrees. That little m means that you're stating the measure. And there are many pairs of supplementary angles up in the diagram. As you can see, many straight angles are formed. And then the final, I believe, final terminology we have for today, same side interior angles. If angles are on the inside of parallel lines and on the same side of the transversal, they actually end up being supplementary. So if we look up here, that means angle 4 and angle 6. Those measures are going to add to 180 degrees. The reason for that is the measure of angle 4 plus the measure of angle 6, they end up actually being in a relationship. So actually, let me back up. So angle 3 and angle 4, we know are supplementary because they actually form this straight line. Angle 3 and angle 6 have to be equal because they are alternate interior angles. So that means angle 3 equals angle 6. So if angle 3 plus angle 4 equals a straight angle 4 plus angle 6 would also in fact create a straight angle. So it's a more of a roundabout way to get to these relationships, but it is something that if you do have memorized, it's a shorter way to get to proving angle congruence. Okay, I believe that's all I have for terminology for now, so that's the end of video 1.